Welcome to The Alchemist, your ultimate mathematics Cambridge exam strategy explainer. Today we are focusing squarely on syllabus code 0580. Our goal? To take your raw, basic mathematical knowledge and transform it into an absolute gold standard evaluation that examiners cannot help but award full marks to. Now, I see thousands of past papers, and I constantly see two types of students. First, there's Alex. Alex has memorized the textbook, overloads the page with raw mathematical facts, but offers zero actual analysis or clear steps. Then there's Sam. Sam is always in a rush, completely misses the command word requirements in the prompt, and throws away easy points. We are going to fix that today by connecting the visual beauty of geometric transformations with the underlying language of vectors, and we're even going to look at the rich history of the mathematicians who literally made all of this possible. We're going to treat this explainer like an interactive masterclass. I want you to stop seeing mathematics as just a bunch of abstract rules you have to memorize for a Cambridge exam. Instead, we are going to look at the visual reality of these concepts, learn how to decode exactly what the examiner is asking you for, and guarantee you're maximizing your mark potential. Here is our strategic agenda for today. Part 1 is visualizing mathematical transformations. Part 2 is the language of vectors. And Part 3 is Italian pioneers of mathematics. We are going to move from visually grasping spatial movements to defining them with vector code, and finally, we'll meet the brilliant minds of the Middle Ages and Renaissance who basically invented the tools you're using today. Let's jump right into Section 1, Visualizing Mathematical Transformations. This is where we lay down the foundation. We are going to ground our syllabus knowledge in the physical reality of how objects move and change in space. Okay, look at this. Notice how the flawless, natural symmetry of these mountains on the water perfectly captures the concept of a mathematical reflection. Take a moment to really look at how the peaks invert across the waterline. Now, this isn't just a stunning photograph to look at. It's a living, breathing example of spatial geometry in action. When we talk about plane figures shifting or mirroring on an exam paper, this is the exact physical reality we are trying to map mathematically. The biggest mistake students like Sam make in an exam is looking at a grid and completely panicking because they just see abstract lines. They don't take a breath and visualize the physical movement. If you can picture the mountain reflecting in the lake, you can picture triangle A reflecting across the y-axis. It's the exact same concept. Visualization is your very first strategy for unlocking these questions. That natural mirroring brings us directly to the specific requirements you'll face on Paper 2 or Paper 4. According to syllabus point E7.2, you absolutely must be able to recognize and construct 4 key plane figure transformations. These are the fundamental building blocks of spatial geometry. We've got reflections, exactly like our mountain lake, where you need to identify the line of symmetry. We have rotations, specifically through multiples of 90 degrees, where you must state the center of rotation in the angle. Then we have translations, which are your straight slides without any turning whatsoever. And finally, enlargements, where figures scale up or down based on a specific scale factor and center of enlargement. Now, when a Cambridge question uses the command word describe fully the single transformation, this is where the strategy kicks in. Students like Alex will write a whole paragraph but miss the core details. If it's an enlargement, you have to give the center and the scale factor. If it's a rotation, you need the center, the angle, and the direction. Missing even one of those is throwing marks out the window. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's keep building this system. Your goal is to look at a plane figure and immediately decode which of these 4 movements happened. Let's move into Section 2, the language of vectors. If visualizing the transformation is the first step, vectors are the precise vocabulary you need to write your answer perfectly. The absolute crucial point here is that vectors give us the actual code for a translation. They show us exactly how far and in what direction an object is moving. As outlined in syllabus point E7.1, a vector is represented visually by a directed line segment. But when we need to write this out on our exam paper, we have specific notations. We can describe it as a column vector with an x value over a y value. The top number is your horizontal shift, left or right, and the bottom number is your vertical shift, up or down. You'll also see it written as a bold letter A or as a directed segment from point A to point B with an arrow over the top. This notation is the universal language for spatial translation. A massive tip here: when you are handwriting this in the exam hall, since you can't write in bold text, make sure you put a little line or squiggle under the letter A or use the clear arrow notation for AB. Don't let poor handwriting rob you of a grade boundary. Once we actually have that language locked down, we need to manipulate it. To fully master syllabus point E7.1, you must be able to confidently perform 3 distinct operations. Number 1, you need to know how to add vectors together to find a combined translation. Number 2, subtract them. And number 3, multiply a vector by a scalar, which effectively just stretches or shrinks that directed line segment. This is where I want you to apply a structured framework when answering long-form vector geometry questions. Think of it like making a solid argument. First, you point out the operation needed. Are we adding two paths together? Next, you provide the evidence by writing out the column vectors clearly. Then, you explain your process by showing the arithmetic, literally adding the top row and the bottom rows separately. Finally, you link back to the question by stating your final vector clearly. If you structure your vector math like this, you leave absolutely zero room for the examiner to doubt your understanding. By mastering these operations, you can express any given vector in terms of two coplanar vectors, allowing you to solve those high-mark, complex spatial movement questions at the end of the paper. And this brings us to a brilliantly elegant formula from syllabus E7.3. This allows you to take that vector code and calculate the exact magnitude, which is just a fancy mathematical word for the physical length of the directed line segment. When you have your column vector of x over y, finding the magnitude is as simple as taking the square root of x squared plus y squared. Look familiar? It should. It's basically Pythagoras' theorem applied to a coordinate grid. You take your horizontal shift, square it. Take your vertical shift, square it. Add them together and root the whole thing. It is a beautiful formula that ties our directional code right back to measurable physical distance. If you see those vertical bars around a vector symbol on your exam, that is your command to use this exact formula. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's dive right back into it with Section 3, Italian Pioneers of Mathematics. You've got the modern exam strategy, but now I want to humanize this subject. We are going to travel back to Italy to meet the pioneers of early algebra and arithmetic, the ultimate alchemists of mathematics. Now, before we could ever calculate vectors or graph complex transformations on a Cambridge exam, this man had to pave the way. This is Leonardo Pisano, who lived from 1170 to 1250. But you probably know him today as Fibonacci. He revolutionized Europe. He didn't just invent mathematics out of thin air, though. Rather, he was an incredible synthesizer of knowledge. He introduced vital new methods of arithmetic to Europe, bringing them over from the Hindus, Persians, and Arabs. He was essentially doing what we are doing today, taking complex information from different sources and figuring out the absolute best, most strategic way to apply it. While he is overwhelmingly famous today for discovering the natural sequence that bears his name, you know the one, 1, 1, 2, 3, 5, 8, and so on, his actual impact on the math you do every single day was much, much broader. His groundbreaking book, Liber Abaci, fundamentally changed European mathematics forever. He introduced the decimal system. Think about that. The very foundation of the algebra we just used for our vector magnitudes came from his work. He also introduced the lattice method of multiplication. Interestingly, while many modern history books claim he brought Islamic mathematics to Europe, Fibonacci himself, in the introduction to Liber Abaci, very specifically credits the Hindus for these numeral systems. He took the best tools available and systemized them, which is exactly the mindset you need when you walk into paper 4. Because he provided the vital numeric foundation we use for literally all modern vector geometry, historians often bestow this incredible title upon Fibonacci, the most talented mathematician of the Middle Ages. It is a massive claim for sure, but when you consider that he essentially recoded how the entire Western world processed numbers, it's a title that is really hard to dispute. In your studies, you should aim to emulate that level of mastery. Don't just blindly follow the steps, understand the mechanics behind them. When you understand the why, remembering the how during a high-pressure exam becomes second nature. Let's move forward in time and see how this knowledge builds across the centuries. Contrasting these two eras, we see Girolamo Cardano pick up the mathematical torch during the Italian Renaissance, where Fibonacci laid the basic groundwork in the Middle Ages by introducing Hindu-Arabic arithmetic. Cardano took that algebra to entirely new heights during a period when art, architecture, and science were absolutely flourishing in Italy. This transition is exactly like the jump from core mathematics to extended mathematics in the 0580 syllabus. You take the foundational rules and you start applying them to far more complex, multi-layered problems. Cardano's crowning achievement was his book Ars Magna, which literally translates to Great Art. Published in 1545, it was the very first algebra book ever published in Latin, and it was met with massive, widespread acclaim. In it, he showcased entirely new algebraic methods, including groundbreaking calculations for solutions to cubic equations. But here is an incredibly fascinating historical footnote. Even though he continued to study mathematics for the rest of his life, Cardano never published another mathematical work after the highly acclaimed Ars Magna. Yet that single, perfect publication cemented his legacy forever in the history of algebra. When you sit down to write your math exam, I want you to treat your paper like your own Ars Magna. Lay out your steps clearly, show you're working, turn your mathematical logic into a piece of undeniable art that the examiner can perfectly follow. As we conclude this strategy explainer, I challenge you to look at modern syllabus questions differently. Whether they're asking you to reflect a plane figure or calculate the exact magnitude of a column vector, I want you to recognize the centuries of great art and algebraic innovation that makes solving them possible. The math you are studying today is the direct result of pioneers like Fibonacci and Cardano. You have the ultimate toolkit, now it's just about execution. Remember our system. Decode the command words first, don't rush like Sam, apply a structured, logical framework to your answers so you don't just dump raw facts like Alex, and manage your time matrix so you can finish every question. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to absolutely every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep visualizing, keep practicing, and I will see you in the next strategy session.